build this course specifically is that they conceived it in a way that they've created lots of different branches, Git branches, of course. And then basically whatever you do inside of a single step, if you mess up something and you cannot figure out what needs to be done, what's the correct way, so you can always do a git checkout and you will get all the files downloaded for you, available in your folder, and you can view it in the Business Application Studio, and you just need to run it, and that's it. It works. So you can see the ending state. So you can try to do something on your own, and if you cannot figure out how it works, you can just do the git checkout and you get all files, the completed step for you downloaded. So, and we're going to use that right now because we definitely don't have time to type things, right? It will be impossible for all the files. So we're going to do some git checkout after every step and just have everything downloaded. I'm just going to display the files for you so you see how it works, because this is not the coding exercise. You can try to do something on your own. If you get confused with what exactly you did, something's not working, again, I repeat, git checkout, you get all the files automatically downloaded. And here it is, like every step. Of course, always use tab. Don't try to type these long names, just type the number of the step. For step 1, it's going to be 0. Because Milton is like a typical coder and he likes to start from 0. Step 1, step 0 over here, git checkout. So repository. Again, it's not, this is Milton's public repository for SAP, but it's not like an official SAP repository because it's a long procedure to have something included in SAP GitHub where other code is kept. Would be almost impossible for a course like this. This is again Milton's own SAP employee account in Git, and you can use this one, or you can just fork this repository if you needed something, if you need it for a specific purpose, like the last step. So always we will have some commands that need to be executed over here, and you can do it by command or just get the file downloaded. It will start like this. I'm quickly going to do that. So over here in Business Application Studio, let's say that the actual start would be, I think this will be the root folder for us in our learning journey over here. And if I would log in, I would get the project. So I think let me just see if I have time to remove it now. It's 5:25, probably wouldn't be the, let's not remove this one. Let's just use it. I'm going to show you how exactly you're going to get to this specific step if you do it on your own. So basically your empty project would start with, you will build a sub account over here, and Business Application Studio is something that you access through this link, right? It gets loaded in your screen. The list of things that you get available on the screen when you click on Business Application Studio is the list of development spaces over here. So this is just one that I created for the specific exercise. You can create a dev space, and here is what you get on the screen. It's all the things that you can do inside of the SAP Extension suite. It's not just the cloud application programming model, like something if you want to do some extensions for HANA. So this would be one choice. Other option, something which is more in Fiori space. I'm also going to use Fiori for the cloud applications. For us, it's going to be full stack cloud application. You put the name of your dev space. So for example, it would be Ocean Dev Space 2 for myself. And these are the extensions which are predefined for you. So you don't need to do anything over here. You can just click Create Dev Space and Finish, just to give an explanation for what exactly we see over here on the screen. So this is something that is, when you say full cloud stack application, you get a list of predefined extensions automatically included. So you definitely need the basic CAP tools like CDS. something basic for Fiori, like Fiori elements you need for sure. You will need Java also, but we're not going to do Java because Node.js is usually the, let's say, the most standard choice. We're going to do Node.js. And MTA, the multi-target application and tools that we basically need to build packages and deploy this application that consists of different modules, very different technologies for different target platforms. Tools like that, we're going to need it all. If you need something extra, you can activate it right here. Take that one and activate it. You say create dev space, and immediately a single dev space is created for you. So again, development space that's a Cloud Foundry term. It's the it's like maybe we need to do that like for a couple of moments, brief touch on that also. Through history of let's say you do all of you guys do, I guess all of you do something with cloud computing, and you have some, let's say, significant experience with cloud computing and usual web development framework that goes with it. You know how the history looks like from on-prem to standard virtualizations, like virtualizations which are on hardware level, of course, when you use cloud services from providers, when you get something which is like on demand and automatically scaled by providers. In the backside, of course, it's implemented with some kind of virtualization. So historically, when everything started, it was virtualization which is hardware level. You get a virtual machine instantiated for you. Then inside of the virtual machine, you get things like operating system and let's say the applications that go to the top. Of course, there are a couple of layers in between, but whenever, for example, if you go to Amazon Web Services and you purchase some specific service, then a single instance of virtual machine gets loaded for yourself. Of course, that's like there's some image of that virtualized system which is kept and immediately instantiated. It takes time, of course, for all that to load, because the only thing that is virtualized is the hardware of the system itself. So historically, it progressed. People were looking for some, let's say, technological means to get that lighter, and then we got to something which is container virtualization. So what is basically emulated is not the physical hardware of a certain machine, but it's the operating system itself, because there's no really need, for example, to load a whole of Windows or Windows Server or Linux every time. That's same for virtualization machines, right? We don't need to load it every time. Maybe if we get it also prepared in advance, so we do not just emulate the hardware, like the microprocessor registers and things like that. We do something which is like operating system level virtualization, and then we got to the actual containers, right, which you can think of as a lightweight virtual machines. Of course, if you have a container, which is a very lightweight machine, then you need something to orchestrate all those things. And then it's easy. Like then you get systems like Docker, which basically enable you to build a container and do tasks about a container. But if you do something which is like let's say some real life use case and enterprise level use case, then you have lots of containers. Then you have things like you need something to orchestrate it, because you cannot work with thousands of containers manually and maintain each of those and be aware of all individual components inside of the big puzzle. You need some orchestration systems. Then you have Kubernetes on top of it, for example, one or like a tool of choice. Then things that build on top of it, Cloud Foundry, right? And Cloud Foundry basically doesn't work with with containers as, like, say, the main currency, or it works with applications itself. So it enables you It gives you the full life cycle of an application. So most of you guys over here, probably there are some guys who do lots of Cloud Foundry development on Cloud Foundry as the platform. So you know much better than myself what exactly it is and what it offers. Some guys don't have any experience. So people who do Cloud Foundry and who deal with dev spaces, like spaces inside of Cloud Foundry as the main development unit and isolation level, know very well what it is. So here we just built another Cloud Foundry dev space on this click. So I myself, I'm currently going to use this one. Just let me get back to where I was a few moments ago. It's my own Dushan dev space over here. You need to run it every time. It takes a minute, something like that, to run. So it's basically, when it runs, it says running, you can just access the dev space, and then the business application studio with the old code that we have in the background gets loaded for us. So just give it a few moments. This amount of time that you wait for the business application studio to load, the equal amount of time you need to wait for that one to run. So this is like what you get, like every time before you start your working environment. So I already have this risk management project for myself over here. This is what we did a few moments ago. Let me just, nothing else I think I have here. The console is a bit slower, so if it's, I'm just going to open a new terminal. Always you have you can easily open a new terminal from here. So what you're going to do for this particular exercise, it's basically very easy. I'm not going to repeat it now. I'm just going to try to save a bit of a time over there and not start absolutely from scratch. So your start is going to be this. So cloning this repository. So when you clone that one from your projects folder for your user, you're going to get a single folder risk management created just exactly as the one that I have now. So you don't have to create manually over there anything. The only thing that you can do is just have that one opened over here. So you navigate to the actual risk management folder. So it's just like workspace. You just create a new one, add risk management, so you have it visible on the left side also here. So it should be just copy pasting of this for yourself, and you get the risk management folder with all the files. I think this is probably some of the versions that the last run that I checked out yesterday when I was testing it. So over here, I'm just going to enter the folder now. Let's say that I've just downloaded it. And then you play with branches. Manually, if you would be doing that, you would be saying CDS, init, and then name of the project. And then you would get a couple of basic elements inside of your project automatically instantiated. So let's talk about all these things that we see in the screen currently one by one. So what is CDS? So that's basically a facade object that gives you a whole interface toward Node.js APIs. So whatever you need from Node, you would, most of the things you would access through CDS, and also lots of tools that SAP offers in that domain. Lots of, let's say, useful tools. You can access them through CDS. It's not the only thing that we will need for sure as part of this exercise, but an easy way to get the basic elements of your cloud application programming model automatically instantiated is to say CDS in the name of the project. CDS again is something you've seen it as part of the tools when I've shown you the automatically provided extensions. When we created that dev space, right over there, CDS is something that gets provided to you automatically by the project type that you've chosen. If you do like everything on your local in Visual Studio Code, then things like that, you have to make sure that those all get installed. So you get latest version, you wire up the things correctly. So this is why I always go for the easiest possible way. Again, it's really up to you to decide what exactly you want to do. So what I'm going to start from this step 1. So I'm going to say git checkout 0 and initialize project, and just, what is this? Okay, so let me see what I have changed. Index HTML. So let me just revert this. Should be this file, right? It's the, if I remember well, this one is going to revert the, let me just see which one is that. That's the app risks index. Let me just see the list of the files that I have over here. It should be, so this one, right? Just to revert a single file. App risks web, no. Let me just reword this one so it can, if I remember well, this should revert changes right on the index HTML. Right, that's it. So we're going to apply the same thing on the DB, but this is not something I remember I've changed. Definitely not yesterday. Let me try that one once again. Okay. So let's revert this file also, whoever changed it. I really expect it's going to work now. So git checkout, let's do the first branch. And here it is, it works. So just give it a few moments because I definitely don't expect all these files to see in the left side. So let's just, you can do it, trigger it manually, this loading. Just give it as much time as it needs to reload. It's never this slow, but I don't know what's the goes now. So I expect this list to get significantly reduced. So here it is, like the bare bone structure of my project over here. So what do I have over here in these folders? So database, DB, is basically generated. Okay. So database is basically where I'm going to store all files which are related to my own data model. Services is where we'll, of course, keep the services definitions and whatever we need to expose for our service, for the application to work, we're going to keep over there. And let's say that the app is where we're going to store UI files. Again, this is not obligatory. As for every Node.js project and the cloud application program on top of it, you can put files at positions where you want. This is just the convention. So when other people use your code, they can easily navigate through a plethora of files that will be used. And pretty often in those files, as you will see, whenever a certain file starts, we will do some like inclusion of the old content from other files, and we'll be using paths and say require and give the full path to a file. So just give me a second because this one doesn't look like I expect we're just going to get a single file, or maybe the first step is like, yeah, it's completely empty. Nothing else. So let's just talk briefly about these about what we use over here from technologies on this level. So Node.js. So what's the idea? Again, one of the things that is constantly being mentioned and one of the buzzwords around, it's many of you know that the idea is that you have the runtime JavaScript environment that runs at the backend. So you basically, with Node.js, which is kind of 10 or plus years old, you get the possibility that to code the backend of your application in JavaScript the same as you do with the front end. So idea is to technologically unify the whole stack, and that you don't have different groups of people developing different segments of the app. So Node.js, again, is a very different topic for itself, and as many other technical topics that we will not mention over here, we definitely cannot afford ourselves in these in such a short academy focused on a very specific SAP topic to talk about details of that, but we have to use all those technologies. So I'm just briefly going to mention those. As always, some guys over here have like probably a decade of experience in that field. Other guys never heard of it, so we have to balance with that diversity. The idea of Node.js is that you have a JavaScript virtual machine that runs in your server side in the backend, and you're able to code the logic, the business logic of your service in JavaScript also. So the idea is unified technology. So package JSON is something which is very typical for every Node project. So it's description of the actual project itself. So it comes. That's one of the required files, and some of the most typical files that you will face. It basically gives some basic properties of the actual Node.js module, because we're going to mention where exactly this is also used. The name of the module, the version, description, details like the actual what type of the module it is, like what type of the licenses it can other people use your Node.js module, like for commercial purposes or not, what's the actual type of the license. These are the dependencies, the other Node modules that your Node module is dependent on, something that is used only if you build your code for development purposes. So these are called dev dependencies. And other things you will have here. So this is just the code version that was checked in for this basic project, a similar one that that Cloud Application Programming Model would push over here for you if you just say, give me a new full stack project. So where also is this used, and what pretty often you will be using? So like in this particular case, although I don't think it's going to be a problem for myself because I already have it installed. So it says like missing dependencies. So pretty often you will be using NPM, Node Package Manager. So what is NPM? It's probably the biggest database of software in the world, but it's also the default software database for Node.js, and it's specifically it's specialized for JavaScript packages. So you basically build some Node.js module, you publish that one to NPM, and NPM it's also the repository of packages, but it's also the client tool that enables you over here to work with the repository and download packages that you need, inspect what's available in the catalog, then deal with the dependencies and things like that. So you would usually say npm install to resolve issues like this, although this is something that I see with a specific project that I think this is going to work, and I'm not really sure why it gives me like missing instances. But anyways, we're going to resolve that one if that really gets to be a problem. Let me see, there's something else that I want to mention over here. So this specific one, which is like CDS RC JSON, this is where you can add some configuration which is specific for this project that can override some properties. And because this is fully empty, nothing else which is that important over here to mention. We're going to go slide by slide and we try to explain all the things that we run into, because it's going to be a lot of lots of overlapping things. So we've initialized a full stack project. The first one, so you get the bare bones structure for what you need to build your cloud application programming app, the very first app. So now a couple of next steps that we need to do. We need to provide some data model for it, and we need to expose the data model and build some service. So I will be talking, and when a new technology or something which is of interest appears when we run into that one, then I will introduce it to the story. Again, I'm doing that now, and I expect you will be using the same thing. We already mentioned, like, just to remind you, we mentioned, like, we talked about the exact learning journey, the screenshots, the descriptions of the files and the projects that you have. You have it over there also. You can also you can use the recordings of these videos afterwards. You can use the decks, the very ones that I'm just sharing to you. And you also have an extra step that you can just check out everything, and you don't have to build it on your own, and you can just inspect what's available. So lots of different channels. We really tried to provide multiple of those. So we just increase chances that you complete it successfully, and that we have you tied to the technology. So over here, this is the, so let me do the checkout number one. App always gives you the completed name of the branch. I have two. Okay, that's the reason. So let me just see one. Data model, I have multiple. So I'm going to do this one, git checkout one, data modeling. And here I am. I get a couple of files. So now we already get some content to talk about. The first thing is the data model. So as always, we need to define some data that our application is going to work with. So many different technological frameworks use different solutions, and I guess that you've used many, like in your previous experience. But over here, we're going to use something which is quite ubiquitous with SAP World, specifically CAP. It's the core data services. So core data services basically gives us, we're going to talk about more details afterwards, but two main things we're going to do over here. It gives us the syntax to describe the actual data model, which is the file that you see here. And then it gives us also the syntax to very quickly expose a web service. This is something that you will very often see in relation to cloud application programming model, and the story that we slowly started to introduce. The idea is not that you crash your hands while coding and trying to put some framework in order to work and start working. The idea is that you have some, let's say, pretty minimized syntax, and afterwards use things like annotations, and with a really minimal set of steps, you get the full application working. And it's always going to be the same couple of things that you need in a very minimized syntax. Over here, we have two entities. Our specific app, that's just a business case, a fictional business case, not really important for the actual topic that we want to cover over here, which is the technology itself. But we're just going to build an app which deals like lists, risks, and mitigations, and shows a couple of basic properties for risks and mitigations objects. Of course, mitigations are always tied to risks. In our own particular case, it's the multiple risks can have the same let's say, mitigation measure as a solution. So we just want to play with that association, which is one-to-many over here. So we build two data entities. As always, when you use some syntax to describe some data model, this, of course, needs to be pushed to the database at the end. The idea of describing is a data model is, of course, like one of those is, of course, that you don't have to write those long lists of extensive SQL queries and push everything to the database. Prepare your data model just in order to use it. You do something quite short as this one. This is not, of course, the first syntax for that is used for creation of and describing data model that you've seen in your life, but core data services, many of you see it for the first time. Here we say we're going to use two entities, risks and mitigations. And what is managed? So as always with Business Application Studio, you can, as people, for example, who worked in, I don't know, Visual Studio itself, or Visual Studio Code or some other clips, like you always have tools like this. You can do something like go to definition and see where exactly that is defined. So let's see what exactly I did now. So managed is basically an aspect. The guys who do aspect-oriented programming and mixing have idea of what exactly this is, but in short, it's like when you use inheritance in programming, it's quite cool and useful thing, but you also face some problems which are quite known with inheritance. So heavy coders know things like, I think it's called like the diamond problem, whatever, however those things are called with inheritance. It's like you'll probably remember issues with multiple inheritance and things like that when you did C++ or C# or things like that, or other language. I mean, you remember discussions with like with why multiple inheritance is not a choice, like what are the issues with single inheritance. So inheritance is pretty cool and useful, but you have also some issues that come with it and also some unresolved problems. Mixed sense are kind of a solution for that. It's like you do not inherit in class, but you use some class with light implementation, like properties in this case, that basically adds functionality to your classes. So you say, okay, I'm going to inherit behavior from some aspect, not inherit, but I'm going to take behavior from some aspect. So you basically add the functionality of that mixing class to your own class. And that's what's used over here. No need to go into those coding details. The whole point of this managed aspect is to do what? Just to add 4 properties to our own entity. So I'm defining risks over here, but inside of the aspect managed, which is defined by SAP, I get 4 properties. When this was created, by whom it was created, when this was modified, and by whom it was modified. So it's not rocket science. It's just 4 properties. And because I need these properties for absolutely every entity in my system, I'm not going to copy paste this, of course, every time. I'm just going to say, okay, my risk solve entity takes behavior from managed aspect. And this is it. So of course, the idea is, where is that managed aspects defined? Well, here it is. Here's where it is. Like SAP CDS, that's SAP published npm package, the Node.js module. So this one we used from the public repository. Common is just the, like, again, that's a folder branching inside of the package itself, the structure itself, and this is managed is defined. So I'm just saying I'm going to use this managed aspect from this particular place, and this is it. Okay, so now I define my entities. This is just a namespace over here. Namespace is not really much in this context. It just gives us like it makes sure that the entity that I build has a unique name. So my entity risks is not named risks. Its actual name is risk management.risks. So whenever I use it somewhere around, I'm pretty sure that wasn't like some other guy in the project who defined the same entity, risks, because we all deal with risks-based applications, and then of course we get a wrong reference. So this is like just a namespace at the top that I define. I say just make sure that this is my unique name for the entities. Risk management, risks. Okay, so now I define basic properties, right? Kind of resembles like a database table columns. And I defined the type over here. Again, not, for example, like in SQL, like I do on varchar and things like that. Over here, I use the syntax of CDX, right? Something which is like natural and familiar to coding people and not to like people who are from databases. So over here, I do string. Then this is the first place where we meet something which is called annotations. And that's a very important term for cloud application programming model. Because over here, what I do now, it's like I'm not, this is one of the ways to define an annotation. And I'm quickly going to show you another one. So this is everything you need to say. Here is an annotation. Annotations add extra properties to our own entities and the actual the columns or the properties inside of the entities themselves. So they add extra characteristics, behavioral features. But the idea of the cloud application programming model is that, like, if there are any guys who do Java over here, for example, and who did lots of standard Java coding, so you know how it goes. You put everything in code. So you put your hands on the keyboards and start typing, and you produce classes. The idea over here is that you don't code things, but that you get some basics provided by, most of the things provided by SAP. Things like the actual entity, well, that's something that you really need to define. But then you don't code behavior. You just say, okay, I'm going to, this is going to be computed by the system itself. So the unique identifier. And I just want to say, like, I'm not coding it. I just describe to the cloud application programming model of what exactly we want to use. We're going to use some more interesting annotation. This one, but this is the very first moment where we actually face a single annotation. So I'm saying, yeah, this is going to be automatically computed by the engine. This resembles like a lot like an automatically like the auto-incremented ID in the databases. Nothing much in this specific case, but in the same syntax, we're going to add all other annotations. And in a few moments, a new one is going to appear, because it's not the only way to add an annotation. The idea, the point is that you don't code things, but that you just use something which is in the metadata form. So annotations you just need to specify annotation. You say, okay, this entity or this property is annotated with this, and it immediately gets the behavior. So it's usually going to be just like a few words, but it's going to be a very large set of functionality that gets functional behavior that gets added to that specific entity. Okay, so now the annotations are not such a big puzzle. So when you run into this sign, it's not something unknown. It's just how we mark the start of a single annotation. And that annotation can be like, they can be syntactically, they can be specified in different ways. So it doesn't have to be a single line. It's usually going to be like something like you just have the annotation mark and the symbol over here and the open bracket, and then you have multiple lines of annotations one by one added and just closed at the very end with a bracket. So it can be multi-line, it can be very long, so you even forget when it started, but it's just the list of annotations that are assigned to a specific entity. And I repeat, that's the philosophy of the framework. So not to code behavior, but just to annotate specific behavior to an individual entity, meaning like specify on the metadata level if it takes a specific behavior from a certain functional behavior. So let's see what else we need over here. Again, so you have everything clearly stated out. So you don't even have to do things like what you can do inside of Business Application Studio, which would be quite a cool point to introduce, like how you work with Git over here in the Business Application Studio. For example, you go to this place Git, view file history, and then you get the whole history schema. Now I have just a single version over here, but you can check everything and even compare different versions. All of them are going to be listed over here. You're going to do that in the very next branch, the very first time when something changes. You can work with Git. It's integrated, of course. So you can check every file. This is Milton, this picture. So check versions, like check history, everything that was committed, it was checked, committed inside of that single group of files. So things like that you can work with over here. Again, we don't expect you with this particular exercise. We really tried to minimize your effort. So we listed all the files changed over here. So you just do the git checkout, and then you say, okay, here are the files which are changed. So you just go file by file, one by one, to see what exactly is interesting in this specific branch for this specific step. And I'm going to do the same thing now. So let's see what are the two files that we just added to data. So schema CDS, as I said, in the database DB folder, that's where we usually define our data model. So let's see what else I got with this checkout. It's the 2 comma-separated value files. And these are the first samples that we will be using for testing. So in a few moments, I will run CDS watch, which will run the local testing server of our CDS server. So this is not, we're going to get whatever we have currently automatically run, but again, not in the Cloud Foundry environment where we need to deploy things at the end. This is just the local testing instance. Of course, in this case, inside of your own PDP trial sub account. Before I do that, let me just check what I have. So here it is, like the things that we had for risks a few moments ago. ID created at our priority description. So they're all listed over here. And I get 3 lines, 3 different risks objects describing the comma-separated value annotations. The same thing I have for mitigations over here, the list of 4 objects. So when I do CDS watch, I'll probably get very, very little. It builds all the files, and we get the exact place where we can check what's available. So currently I have nothing exposed, and we're going to make just a single change so we have something exposed, because we didn't expose web service yet, right? So I don't see anything on my web service, although the data model is in the background. But what happened now is that, like, so the idea is that, like, everything was built in a way that let's say it gravitates toward, like, that we minimize the actual amount of code that you need to do. Of course, it's not low code because this is a coding framework, but let's say that the idea is that with this framework and other things which are much more helping in that code, like Fiori elements, the idea is that you just specify a couple of things and the framework does most of the job for yourself. So things like we over here defined the risks entity. So we want some data loaded to our own app, a couple of entities that are, let's say, we want something filled inside of the database for the start. So we want some content in our database. How do we do that? We, for example, use comma-separated value file. It's just one of the ways. You just put the namespace, then dash, then the name of the entity, and you place that one into data folder inside of DB. And the system will automatically pre-populate the tables for you. So that's one of the things. So no code is added. This is just a way to quickly initialize something in a database from comma-separated value file. So everything else is provided by a framework itself. We just define schema CDS. So over here, I probably didn't mention only this association, which is kind of a different for mitigations. It says, okay, I have a risks field, which basically links to this very risks object. Because this is one to many, it's not like a simple association like in this case, from risk to mitigation. It's the It's basically, it says it's associated to many risks, but it has to be like a backward direction over here in a way that risks.meti, which is the specific field, is tied to myself, my own object. Right. So that's just the way to specify when you have like one-to-many annotations. So I think that I've covered everything from this file. We're not going to cover everything from all the other files for sure. This one was quite basic. So I said CDS watch, and you always get that place that you can like instantiate it locally inside of your sub account, something that you can test. Okay, so let's go further. Here we have the data model is something that we covered already. Makes sense. It's like all of these materials you will get, so you can read it in more details afterwards. We covered the files and we completed the data model, so we go fast toward the next steps. Like we need to expose a web service. So the natural question would be, why is this section where you basically expose a web service titled generic handlers? Well, that's because the whole cloud application programming model is event driven. So you basically have lots of system events, and you just basically define your handlers for those system events. And we'll do that. That's not something we'll do that during these 2 days. To Java guys who have to JavaScript coders, which is not myself for sure. Like I wouldn't describe myself as that, but guys of you over there who do lots of JavaScript coding constantly and just that, they're quite used to that. Let's say to the coding paradigm, and they think in that event. Let's say it's easy for them to code for event-driven models. They find handlers pretty often. So it's basically here it's we talk about handlers because we have everything we use, what a cloud application programming model as a framework provides for you. It's just the set of generic handlers for some events in the system. So whatever happens, like inside of the app, with your data model, with your service, with your UI, lots of those things, like it's defined in the handlers, and you can use the standard handlers and not even notice them as the standard handlers, of course, or you can change that behavior a bit. So when I say generic handlers over here, we get to one of the first, let's say, value proposals and the architectural concepts of the cloud application programming model, that we use OData as a technology which was built on top of some the most standard technologies in the world, web technologies like HTTP and REST. So basically, we deal with exposing OData web services, which are specialized for cloud operations. So if you want to create, read, update, or delete something, then you just have a simple REST call, and all, let's say that the web services are designed in the way that your communication to the server it's all basically the list of CRUD operations. So creation or updating or reading, deleting some of the objects, we expose all data services over here for that purpose. We're going to do something like that in a very few moments. And we're going to locate all of that mentioned inside of the SRV folder. So let me just do the checkout so I can show you the actual file. So I'm going to stop the CDS watch. Why does the CDS watch run in the background? That's what I see. I didn't mention that. It basically, it listens for all the changes that you do. So if I now something change over here, that will immediately get reflected in the local app. So that's the idea of the testing server, to automatically apply those changes. But I'm going to interrupt the local server, and we're going to do the git checkout. So we are late, but whatever we stop for today. We can doesn't even matter if we don't hit everything. If we don't do everything which is planned, we're going to optimize for tomorrow. So check out two generic handlers. Some basic things we definitely need to cover before the, let's say, additional services. So services, risk service, CDS. So again, pay attention. We describe inside the name of the service as risk service. So everything works on the model it's based on the file name and automatic mapping. So over here is that's the one. So it's as I mentioned, risk management is the namespace that we already defined right before this. So here it specifies where exactly it is. This is just the path. So path inside of the folder. Let's get one step back outside of SRV, back to root, then get inside of DB. Inside of DB, here is where the schema CDS is, right? So that's the file that we opened a few moments ago. So that one I'm going to use. So here's the point of cloud application programming model. So you don't do any coding for to get a web service. Everything you need to do is this. You say, I'm creating a risk service, and what am I going to do? I use the entity risks as a projection on this very data model risks that we defined over here. And this is it. You have an OData, CRUD-oriented web service that exposes your risk entity. Nothing else you need in cloud application programming model. So that's what I mentioned. This thing over here, that's extra. I'm just going to say what this one is. So this is all. Risk is now exposed, so it's visible as an OData web service available to your application to other people who use it. So really minimize set of steps to get a ready-to-use web service. Path over here, that's let's cover that one later. So we're gonna get back to that one. So before this annotation over here, these are all again extra properties that I specify over here. So here's another step to annotate to give some annotation to a certain entity. So here I annotate my risk. So why do you use this syntax annotate and not that one that I've seen a few moments ago, like this one over here? Well, this is because this is the actual implementation of an entity. So look at what I did over here. In risk service, I defined the entity. So I'm not implementation of the entity. I said entity risk, that's a projection to this data model. So it's done. Now I need to add some extra annotation. So if I add something to an already defined entity, so this is the syntax. I'm going to say annotate risk with this thing. So what is this thing? This is just one of the defined annotations. So what does this thing give us? It's basically just the behavior that when I type in something to a text box and I get interrupted, like I get to a different place, the draft in the text box gets saved. This is it. So no coding. I just give an annotation. I say the risks as it's titled over here in the description, it's like interrupted, wrongly spelled. Interesting. So it's basically you give it this is it. Everything you need to enable the draft functionality for your text boxes. Of course, this is just a single one in the sea of examples of annotations. Just a single example to demonstrate the use of the annotation. That's why we use it over here. Not that we're really going to enter any data. So this is it. And I have my web service running. So let me just check if I want to do something else over here. No, I just want to do CDS watch. Again. You get the link, although you can store the link and use it every time. So the first time we have something, very little, just the CRUD operations of the data, but again, quite enough. If I go to metadata, I will get a description of my service. I think this is CDMX, right? Right, this is the format. So over here, if I click on risks, I get all the risks object that I have. This is like currently for the way it's set for my Chrome. It's the very ugly output, but in your browser, quite likely it will be a better formatted thing. So it's I don't think this one is going to work with this mode, but let's just check if you're a preview. If it loads for too long, I'm just going to interrupt it. You can do also viewer preview, not really relevant for this topic. At the moment of this specific object and see how it looks like. But let's not spend any more time on that. We got some basics of the service. Again, don't have anything in the application itself. Not a single starting page, no index HTML to access, just some descriptions of the service that we can access and just make sure that our service exists. It's there in the background. It just waits for us to do something useful so we can really use it. Okay, back to the Business Application Studio, and we're progressing with the next step. This is something that I've already mentioned. This is just the writing of the URL, so we're not going to spend any more time on that. I'm not definitely going to talk about the cloud, the accounts model, the environments you already mentioned. As I say, it's like it's a specific list of steps. Always at the end of the lesson, you have those key summary points at the end of each deck, so you can check it. Lots of useful things. So we're going to run to each of those separately. We definitely don't have time to cover them now. So this is, of course, something that you can do in later when you get the decks and when you start reading it. Just get back to the Unit 3 because we have to progress further. So these are the steps that we completed. The very next thing is we want to add some basic UI. But before that, let's do it in the last 30 minutes because my voice is already breaking. Let's make another 10-minute break. We're going to start with UI, with list report layout and custom event handling. And if we manage, we're going to cover something from the support boxes. So again, it's 6:19 a.m. for myself, 10-minute break. We start at 6:30 for myself. I'm not sure what's the exact time. 10 minutes of the break, guys. So like make a short bio break, grab some refreshments, and I'm going to use it to rest my voice. Thank you.